Welcome everyone. Today I will discuss how to find maximum and minimum value of a function using first derivative test. So to know it, we need idea of significance of derivative and graph of function. So look, this is y equals to fx. It is any curve. So pxy is any point on the curve, and pt is tangent, and tangent makes an angle psi with x-axis. So what is dy by dx? Dy by dx equals to tan psi. So dy by dx represents slope of tangent at pxy. So dy by dx equals to tan psi. Now if psi is acute, then dy dx greater than 0. Here psi is acute, that is, it is increasing in nature. So if psi is obtuse, then 90 degree less than psi less than 1. Then in second quadrant it is that is decreasing function. So this is significance of derivative. Now you know. So for minimum value, you get curve like this or this. So at, if it is a, so at x equals to a, fx at minimum. I am saying about local minimum or local maximum. Now at this point, suppose this is x equals to b. Look, the value of the function is minimum. I have already discussed it, how to find maximum and minimum value. Now, if we get a graph of this type, that is decreasing function, this type. So suppose this equals to x equals to a. So for a plus, if we draw tangent, suppose this one is psi 1. And for a minus, if we draw tangent, then tangent makes obtuse tangent. So this one is y equals to fx. So what we are getting, look, at x equals to a, in neighborhood of a, that is a plus, dy by dx, x equals to a minus, that is left of this. Left of this one. Suppose P1 and this is P2. So a minus. So tangent makes psi 2 and this is obtuse. So dy dx less than 0. So I have already discussed it. Dy dx less than 0. And dy dx at x equals to a plus greater than this point P2, and psi 1 is angle made by tangent and this is acute. So dy dx greater. So dy by dx changes its sign from negative to positive at point a minus and a plus. And this is condition for minimum. So fx has minimum value at x equals to a. This is our condition. Fx has minimum value at x equals to a. Now, take a practical example. So, fx equals to mod x. So, what is the figure? This one. This one. Fx equals to mod x. So, this is y equals to mod x. So, y equals to mod x, x greater than equals to 0. It is continuous curve, x less than 0. Or you can take equal to 0 also. Now, what is dy by dx equals to 1 for x greater than equals to 0 minus 1 x lesser than 0. So, what we are noticing, at x equals to 0 from graph, you look at x equals to 0, mod x has minimum value. From graph, it is clear. Now we discuss it from idea of first order derivative. So, dy by dx at x equals to 0 plus, that is greater than 0, this is 1. We know right hand derivative of mod function is 1, always 1. And dy dx at x equals to 0 minus, it is minus 1, less than. So, look at the definition. At a minus 0, at 0 minus it is negative, at 0 plus it is positive. So, dy by dx changes its sign from negative to positive at 0 minus and 0 plus. So, from first derivative test, you can say fx has minimum value at x equals to 0. So, this is our working. If you forget this, so for 0 plus or 0 minus, you draw the graph and it will be clear. Now, for every mod function, suppose y equals to mod x minus 1. So, what is the graph? At x equals to 1, you are getting this type of V nature. This is y equals to mod x minus 1. At x equals to 1. So, it has minimum value. And from first derivative case, you know right hand derivative is plus 1, left hand derivative is minus 1. Sometimes, second derivative of function may be difficult. In this case, you can use method of first derivative to find maximum and minimum value. Now, for maximum value, so you know graph will be of this type. This is the topmost point, it is greatest for a minus, this is a minus. So, this is psi 1 and this is for a plus. So, if you draw the figure, this is psi 2, this is psi 2. So, dy by dx at x equals to a minus means p1 greater than dy by dx at x equals to a plus 0 or a minus. A plus, this is p2, this is obtuse. So, this is less than. So, this is condition for maximum value at x equals to a. So, this will be eliminated. So, just opposite of minimum value. Now, take a practical example. Practical example. Suppose y equals to minus mod x. We know. So it is y equals to mod x. So minus mod x is mirror image with respect to x-axis of the function y equals to mod x. So figure is y equals to mod x. This one. So clearly, look, at x equals to 0, it has maximum value. Now, if we calculate dy by dx, so this is minus x, x greater than equals to 0, this is plus x, x less than equals to 0, less than 0. So dy by dx equals to minus 1, x greater than, this is plus 1, x less than. So dy by dx at 0 plus, this is 0 minus, this is negative, and dy by dx at x equals to 0 plus, at 0 minus, 0 minus it is positive, and 0 plus it is negative. Just opposite of minimum value. So by first derivative test, you can say that it has minimum value. So you remember, if you take negative of mod, then it has maximum value at the, if it is y equals to mod x minus a. So point is a. It has minimum value at x equals to a. This is general problem. Minimum value at x equals to a. And if we take negative of this, then maximum value at x equals to a. This is our general result. Now, sometime in exam, one problem is asked. So, what is the problem? Give an example for which, derivative does not exist, but it has extreme value, that is maximum or minimum value. So, you are getting the answer. So, y equals to modulus function. Now, derivative does not exist. Right hand derivative, that is f dash 0 plus is 1. Left hand derivative, f dash 0 minus. All of you know it from existence of derivative. I am not discussing it. So look, f dash 0 does not exist because they are not same. So y equals to mod x is a function for which derivative does not exist, but it has extreme value. If it is plus mod x, minimum value. If it is minus mod x, it has maximum value. So dy by dx changes its sign to have maximum or minimum value. If dy by dx does not change its sign, if dy by dx does not change its sign in neighborhood of A, that is a plus and a minus, then the function has no maximum or minimum, that is no extreme value. In this case, we say x equals to a is point of inflection. In this case, x equals to a is known as point of inflection. So let us consider an example. So y equals to x cube. Now look, dy by dx equals to 3x square. So dy by dx at x equals to 0 plus is also 0. Dy by dx at x equals to 0 minus is also 0. So dy by dx does not change its sign. So it has no maximum or minimum value at x equals to 0. Here the point x equals to 0 is called point of inflection. Now it will be clear if you draw the graph of y equals to x cube. So y equals to x cube. What is the graph? So at x equals to 0, you are getting 0. At x equals to 1, it is 4. At x equals to 2, it is 8. It is 8. It is 8. That is, it is increasing steadily. At x equals to minus 1, it is minus 1. At x equals to minus 2, it is minus 1. So you are getting a figure of this type. So if you add, you will get y equals to x cube. So look, no V curve or no this type of curve or this type of curve, this type, this or this. You are not getting. So at x equals to 0, dy by dx does not change. This point is called point of inflection. So at x equals to 0, look, there is one part, so upward, vertically upwards concave curve and vertically downwards concave curve at x equals to 0. You learn later. So point of inflection or point of inflection, if you consider this one, y equals to x cube. So dy dx is 3x square. So d2y dx2 is 6x and d3y dx3 equals to 6. So double derivative at x equals to 0 equals to 0. If it is positive, you know it is minimum value. If it is negative, then it is. So you cannot conclude whether it is maximum or minimum. But if odd order derivative at x equals to 0 is positive, you can say it has no maximum and minimum value. And this point is called point of inflection. So odd order derivative, non-negative. So point of inflection. So maximum value, minimum value, and point of inflection. Now, stationary point. There are two definitions: stationary point and critical point. Critical point. What is the difference? Stationary point or turning point. Now, dy by dx, necessary condition if y equals to fx is a function, y equals to fx, then dy by dx equals to 0. By putting dy by dx equals to 0, we are getting values of x. So the values are called stationary point. Stationary point. Making first derivative 0, we are getting stationary point or turning point. And what is critical point? Critical point is dy by dx equals to 0 or dy by dx. Points at which dy by dx does not exist. So dy by dx 0 or dy by dx does not exist. For example, y equals to mod x. So here x equals to 0 is a critical point. Critical point. Because here derivative does not exist. So critical point is the point for which dy by dx 0 or dy by dx does not exist. And what is stationary point? Only dy dx equals to 0. Look at the curve. At the point, the particle, if a curve is like this, here it is motionless. So that is why the name of stationary point. So you remember the condition for finding maximum and minimum value using first derivative test. So today, through this video, I have discussed the theoretical part and only for 1 and 2 problems, and the point of inflection and what is stationary point. In the next class, I will solve some problem how to find maximum or minimum value using first derivative test. So thank you.